We've been revisiting panspermia and the idea that life may have migrated here from somewhere else. We learned a little bit about the nomenclature, about meteoroid, meteor, and meteorite. Now, how in the world could life migrate from somewhere else? In other words, what's the mechanism? How could this happen? Well, we have some ideas about how this could be possible. Step one, you need an impact. So let's assume that you have some other world where there's a giant impact. This is not a real picture, it's just a diagram. I think it's supposed to be what would happen if something hit the Earth. But I mean, let's say you had life somewhere else, maybe on another planet, maybe Mars, for example, and some gigantic impact would hit. Well, then this could be an asteroid, it could be whatever. So we have some sort of big impact. Well, during that impact, some debris would be sent out into space. So the key thing, so let's just assume that there's life, before. So when this impact happens, if we go back, when this impact happens, let's assume that there's some life there. Let's assume that some of that life basically gets sent out into space. So this one right here, so I'll just say that life sort of hitches a ride. On the rock. Okay, so if that could really happen. So let's assume there's like some little microbe, a tiny little thing, maybe in like a crack between the rock, and a big giant chunk of rock was sent out. That is possible. If that happened, actually, so these pieces right here would be sent out, what would happen next? Well, that material would orbit and get into Earth's path. So let's just draw what happens here. Here we have the sun, let's say. If this is around our own solar system, at least, this would be the case. So here we have the sun. What would happen, of course, is that we would have, let's say, let's just say this stuff which left whatever planet it was, it ends up in some sort of weird orbit. Let's say it goes like this right here. This is a common orbit. So this would be the debris here, or the material. Okay, so this is some sort of material that happens to... this is a process we know that happens, but I'm trying to explain if life did hitch a ride. So the material orbits, it orbits around the sun, and it gets in the Earth's path. Because let's say this right here is the Earth. Let's just pretend this is it right here, and this is the Earth's orbit going like this. Now, of course, we have to assume that they're orbiting in the same plane, but they actually cross each other, but it does happen. So as the Earth is going around, can you imagine some material just sort of going back and forth like this? So this material is going like this, but the Earth is going like this, and maybe they run into each other. Maybe here. Maybe here is where they run into each other. That is possible. And you might think this sounds totally crazy, but we know that this has happened lots of times in the past. I think that's really exciting. So this right here, well, not necessarily there's life on it, but we know, though, that this does happen. We do cross the fields of debris. So assuming there was some life that hitched on, well, what would happen next? Well, that life would enter the Earth's atmosphere because, remember, it would be sitting on this piece of rock that came from another planet. Let's say it was Mars. And, of course, it would heat up. Now, this is a diagram showing what it would look like. This is a real picture of a meteorite actually coming in here. So we could say it's a meteor while it's in the atmosphere here. But as it's coming in, it sort of burns up, but there still might be a piece that's intact. And so this piece might be found on Earth. These are real meteorites that have been found on Earth. So this right here is a big rocky chunk like this right here. It looks very charred. And sometimes you can cut them open, and sometimes you get these really beautiful colors like this with these metals. And these metals are actually thought to be the centers of some asteroids and things like that. But what if it was like some rocky chunk? Maybe that amount or that chunk of rock here ended up with some life on it. Maybe some tiny little microbes or something. And when it landed, maybe it cracked or something. And maybe that life then could thrive on Earth. This seems really far-fetched. Okay, and in fact, we have no idea if this really happened. But what's really awesome is that we're quite sure, though, this process does happen, minus the life on it. But we know that this process happens, that planets do get impacts. Those impacts do send debris out into space. Those debris do run into the Earth. They do come in and enter our Earth's atmosphere and heat up, and we do find them on Earth. In fact, we think that we've found actually plenty of things from other locations. So I think that's really, really cool. So I think that's quite interesting. Although it sounds crazy, we do think that the inner planets have exchanged many tons of rock. So we're quite certain, actually, that this exchange has happened lots of times. So I think that's really interesting, that this exchange has actually gone on. I've heard it said that, we've been sneezing at each other for billions of years. So could microbes have been exchanged as well? That's the interesting thing, I think. We're obviously not sure if that happened, but at least there's a mechanism by which life could hop from one planet to another naturally, by some big impact. Now, what are factors that would affect a life on a meteorite? Well, first of all, if there is life on that little meteorite, maybe stuck in a little crack of rock, it would have to survive the original impact. So that sounds quite crazy. But again, we actually think that it's likely. We think it's likely because the interior of meteorites, those are actually intact. We've got microbes that are locked in small holes, and we think that those could survive. So we actually don't think that this is so crazy. We actually think this is likely, that microbes could survive the impact if there's little microbes hiding inside a little crack in a rock, and a giant piece of rock gets thrown out. Now, could life survive the journey into orbit? Well, I would say it's tougher. So this is not necessarily likely, but it's tougher. And the reason is because, it depends how long in orbit, I think. I could say that. So it depends how long in orbit. In other words, how long did it spend going around and around before it was sort of vacuumed up by our atmosphere? If it stayed a long time, then maybe it's a tough sell. But maybe if it didn't stay very long, maybe it could. And last, it would have to survive the entry into our atmosphere. And again, what's awesome, this one is likely. We're quite certain, actually, that life could survive. And again, the reason is because the interiors of these rocks are intact. There's very little disruption to the interior of it. Of course, the outside may be very charred. And actually, this is a picture of a very famous one called ALH 84001. This is worth looking up because this made scientists extremely excited. This is a rock that they're quite sure came from Mars. Now you might think, how in the world do we know about this? How can we possibly know that these came from Mars, for example? Well, we know that because it has the same chemical composition as Mars and nowhere else. So we're quite sure that this came from Mars, this particular one, for example. There's actually plenty of them that came from Mars. So I think that's really cool. Now, let's go a little bit further here. So what if we did find life on another planet? Now, this is a cool picture. This is a composite. This is taken from a real picture, which is taken from Mars. This right here, this is a crater here that one of the rovers was actually driving around looking at. But this is not a real picture here. This has been added, even though there was a little robot that actually was over here. So they've sort of added this. They've photoshopped this in. But let's just assume that this here is on Mars, for example. What if we found life on Mars? Well, how would we know that it didn't just migrate from the Earth? Because actually, remember I said that, some things have been hit from Mars and those pieces have ended up on Earth. Well, we're quite sure that pieces from Earth have also made their way to Mars. Most of the inner planets, like I said, have been sort of exchanging particles. We've been sneezing on each other for billions of years. So how do we know that life in our solar system didn't all just come from somewhere else? Did some other planet have conditions suitable for life before Earth? Maybe Venus or Mars? But what we would have to do then is we wouldn't be really too sure where the life came from. Let's assume we even found life from Mars. Did it come from Mars or did it come from somewhere else? Did it come from Earth, in fact? Or did life on Earth come from Mars? Maybe there was initially life on Mars and then it, had a big impact. The life basically ended up making it onto Earth and that stuff thrived. But we would have trouble knowing this. So, it would depend on the chemistry of life, very likely, which means if we could find some little life form somehow, even a fossil of it, we'd have to try to take a look at the chemistry of its life. And if its chemistry is very similar to the Earth's, then it would be difficult to tell where it really came from. But if it's water-based, if it's carbon-based, if it's similar amino acids, like these left-handed ones, maybe it's related to us. If not, maybe it's not related to us, and that would be really exciting. But we know that we've been contaminating other places with our own robots already. We've already been landing robots and humans onto other worlds, onto the moon, for example, and on a few other planets. We've actually landed, robots. And maybe we've already been sort of infecting them with our own bacteria. We've landed things on the moon, on Mars, on Venus, on Titan, for example. So we have to be careful. it's not that easy to know where the life would come from, even if we did find life on another planet. So I think those are really interesting questions and different or interesting results. Now we can talk about extremophiles again, and those go back into perhaps supporting the idea of panspermia, that life could have actually migrated from somewhere else. Because if it did, then you'd have to have life that's pretty hardy, that's pretty tough, right? You'd have to have life that could survive this journey and the impact and the entry into our atmosphere. And there exists things that we call extremophiles. Those are life forms on Earth that are found in extreme environments. Biologists have been finding these recently, and it is so exciting. And the reason it's exciting is because, these ones, some of these things can survive super high temperatures, really low temperatures, high radiation, super pressure, super dark, really deep under the ocean, for example, no light source at all. And this might support panspermia, or maybe it just shows that life here is pretty rugged. The fact that they can live in extreme environments, it improves the chances that life could be found on other worlds. We don't have to be so similar to us. Now we have some other experiments that have actually been done. There's lots of them that have been in support of extremophiles. I'm just going to give you just a few of the ones that I think are really interesting. One is the Russian photon M3. So it was a Russian one. This one, what they did, they strapped bacteria and basically some small animals, things called tardigrades. They strapped those to the outside, and those actually survived being in space. So that was a really interesting example that they could survive the interstellar journey. Another one they did on the International Space Station, they slapped some bacteria and other organisms onto the outside of the space station. And some of the bacteria survived, and in fact, there was even a mosquito that survived for 18 months. Now, that mosquito apparently lived, and it was quite exciting that the mosquito actually was sort of shaking its legs, so it was alive in some sense. Now, I'm not quite sure how they slapped the mosquito on the outside and how you wake up a mosquito and how you put it to sleep. I'm not a biologist, but I think it was really, really interesting that they claim that a mosquito at least survived being on the outside of the space station for a while. Again, that just shows that there are some organisms that could survive, the radiation and hot and cold in space. There's another mission. This is so heartbreaking because I thought this was such an interesting mission. It's a Russian one called Phobos Grunt. And this mission was so cool. They were going to go to one of Mars's moons called Phobos. So this is one of Mars's moon. This is a picture actually of Phobos here. It's a really small moon. It's got this giant crater here, and it's actually not very massive. The reason they wanted to go there instead of the moon is because their idea was to go there, land there, take some soil from there, and bring it back. Now, because this moon has so little mass, it has very little gravity. And what that means is it's easy to get off. You just have to have a little kick, basically, and you're off this moon. But if you're landing on Mars, Mars has so much more gravity, it takes a lot more energy to get off of it. So that's actually part of the reason why they chose Phobos instead of the moon, instead of Mars. So Phobos is one of Mars's moons. There's another one called Deimos, for example. But they were going to land on Phobos. And this is a picture of the satellite here as they're putting it together. And the Russians worked for a really long time to get the funding for it. It was so interesting. And you know what the problem, the exciting thing was that they also had a mission where they were going to put some bacteria on the outside of this spacecraft, which would hopefully survive the journey all the way there and all the way back so they could see if it could survive. Although there was some talk that maybe it's going to infect and maybe the bacteria will contaminate Phobos. Possibly. But anyway, they were going to do this experiment to see if it could go back and forth. And you know what happened? It didn't make it out of Earth orbit. Something malfunctioned. It basically went around the Earth a bunch of times. It never made it to Mars. It just re-entered the Earth and sort of died. So Phobos Grunt didn't work. But I really hope they can do one like this. I thought it was really interesting. So these extremophiles, those can help us to understand a little bit about the origin of life. So what did we look for here? Well, how do we look for life? In this part 3 here, we've looked at, first of all, what do we look for? We're looking for mainly the organic building blocks. We're looking for energy sources. We're looking for liquid water. And we're looking for oxygen. Now, the first 3, those are all things that are needed by life, whereas oxygen is something that's caused by life. Of course, we were talking also about the Goldilocks zone or the habitable zone. We discussed a little bit about what aliens might look like. And then after that, we talked a little bit about the origin of life. We revisited abiogenesis and panspermia. Now, these things plus extremophiles, I mean, those help us, to search for answers to our own life. But what I really think is interesting is that, by looking for this, by trying to search for these answers, this leads us, to a search for life on other planets. And so in the next part, we're going to talk about how we're actually searching for life on other planets in our own solar system.